In this class, we are going to uh, discuss the second method in pattern search method. Actually, the methods that use pattern directions. Pattern directions we have defined. So pattern direction as search direction are known as pattern search methods. Okay, and we have two pattern search methods. One is Powell's method. Powell's method. We have discussed this Powell's method the previous class, and the second method is our discussion, that is Hooke-Jeeves method. Hooke-Jeeves method. Okay, in pattern search method of Hooke-Jeeves, there are two steps. Step one, that means you should recall that all these methods are for unconstrained nonlinear optimization of a function f of x. So here there are two steps. Step one is called exploratory. Exploratory search. Mean two steps means two searches are there. The search one is exploratory search. Exploratory search or exploratory step. And step two or search two is pattern search. Okay. The exploratory move is included to explore the local behavior of objective function f of x. And the pattern move is to take advantage of the pattern direction so that the convergence gets faster. Okay. So the local behavior means actually the exploratory search or exploratory move means we have f of x, right, where x is a vector. So x is having a vector and x1, x2, etc., xn coordinates, and so the exploratory search means we will move in all possible directions. We will perturb means perturb, P-E-R-T-U-R-B, perturb the value of x, the value of capital X in all directions, in all possible directions, like x1, x2, etc., xn. And these x1, x2, etc., xn directions are also known as u1, u2, u3, etc., un direction, or in general ui direction. Okay. Yes. Now we are going for the algorithm of Hooke's method. Algorithm. Yes, in the previous method, as in the previous method of Powell's, that is Powell's method, we have, or in the case of any method, we are starting from an initial point known as base point or starting point x1. That is, this is arbitrary. Okay, arbitrary chosen point, and this x1 will be equal to some x1, x2, etc., xn in directions. Okay, then we have also defined a step length. We are defining step length for this is for our local search. That means exploratory search or exploratory move. For that we are defining the step length as delta xi. Okay, for ith direction. Okay, where and the direction is ui for all I equal to 1, 2, etc. n. Okay, then uh, we will find out in the next step that is step 2. The step 2 we will compute fk equal to f of xk. That means we are introducing a new variable k, and that is initially set as 1. So here it will be f1, and that's equal to f of x1. That means our base point, or that is starting point. Okay, we will evaluate our objective function f of x. That is, we will get f1. Then now again we are introducing another variable I for iteration I equal to 1 in order to start the exploratory move. Okay, and we are introducing a uh, new variable that is nothing but yk comma 0, and that's equal to xk. And in this case we are introducing k is 1, so we are assigning this x1, okay, equal to y10 for the in order to start the exploratory search. Okay, and in step 3 we will go for the exploratory search. Now in order to exploratory search, in order to identify the local behavior of the objective function, that is in what direction, that is the objective function f of x is being minimized. That means the exploratory search means, yes, consider this uh, two-dimensional space. Okay, two-dimensional space we are considering. Actually all these minimization are defined for the n-dimensional space. So you can imagine, once you understood the two-dimensional space problem, then you can extend your imagination to n-dimensional space. Okay, this is x1, x2. So what we are doing, we have a starting point, initial point, base point x1 we have, and this x1 is, remember, this x1 is a vector. Okay, x1 x2 vector. Okay, small x1 and small x2. And what the in exploratory search, what we are doing is, we have defined delta xi and ui. Okay, in this case we have delta x1 and u1 direction. So u1 direction means parallel to x1 direction, right? Parallel to x1 axis. So delta x1, what we will do is, in our univariate method, we are searching along the coordinate directions. Okay, x1 and x2 direction respectively. And in the same manner, we will here also we have this, yes, and this x1 is our y10. We have a same. this one. Okay, and now we will perturb this x1 in this direction or in this direction, and we will find a new point. Okay, so that f of x is minimum. Okay, and here we have this point. We will calculate. This is nothing but your x1, okay, plus delta x1 u1 comma is x2, okay, and this point, okay, this point, and this point will be x1, okay, minus delta 1 u1 comma x2, because we are perturbing the x1 only. Okay, and the corresponding f and corresponding objective function values will be, this will be I'm denoting it as f minus, and this I'm denoting as f plus. Okay, so and we will find out. Okay, so in the exploratory search, okay, in the exploratory search, the x1 is y10. That means in general I'm writing it as yk comma I. Okay, here it is yk I means it is yes, yk I means yk I is 1. So yk1, that means new point here. Okay, this point. Okay, this point that will be equal to, is defined as yk comma I minus 1 plus delta xi ui if this f plus, that means f of the objective function value at this point. Okay, actually this yk I minus 1 is nothing but yk 0, right, and that yk 0 is in this case here for first iteration it is y10, and that is nothing but x1, and that is nothing but your x1 in this here. Okay, so that means this, either this point or this point. Okay, so if yes, yki, that means the new new point, new optimum point is denoted as yki, and that will be equal to yki minus 1 plus delta xi ui if this denoted as f plus. So f plus, okay, the value of objective function at this point is f plus. So if f plus, if this is less than our f, that means the value of the objective function at this point, and at this point we are comparing, and this point it is f, and this point it is f plus. So this f plus is less than f, that means this movement, okay, this movement is minimizing the objective function. So you have to choose this as the new point, that is yki, and yki will be equal to yki minus 1 minus delta xi ui, that means this point. Okay, this point, if the value of the objective function at this point, that is f minus, is less than f, okay, or it is less than minimum of okay, it is less than f, actually it is less than f, not minimum, less than f. Okay, f minus less than, if f minus f less than f, then this point you have will be the new optimum point. Okay, that is yki, and this yki will be equal to yk comma I minus 1, that means this point itself, that is our x1 point itself, if f is less than minimum of f plus comma f minus. Okay, so that is the next step. That means first exploratory search. Okay, now the yes, in the next exploratory search, what we will do is this process will be continued for actually this is we have explained in the u1 direction, x1 direction. Okay, and this process suppose this process is further continued for other directions also, that is x2, x3, x4. That means u2, okay, u3, u4, u5, etc., un directions also. That means suppose this is our uh, new perturbed point, new point, right? That means this point, that is yk I minus 1 plus delta xi ui, okay, where I equal to 1. Then this point you will get, and from this point we will repeat the exploratory search. Okay, exploratory search, that means earlier it was yk1. Okay, now it will be yk2. Okay, yk2, and this yk2 from this yk1 we will get yk2 by the exploratory search in x2 direction, like this, x2 direction, either in this direction or in this direction. Okay, so that f is, so it will be the new f plus and f minus, and this is will be the new f, and again we will compare f plus, f and f minus, and whichever uh, which and we will analyze the minimum in which direction the function is got minimized, and we will choose the new optimum solution, that is yk2. Okay, in this manner we will continue our process up to n coordinate direction. Okay, in this case we can stop this up to this moment, because we have two coordinate directions, u1 and u2. Okay, so we will stop here. Okay, suppose, okay, that is the process, that is what you mean by exploratory search. Okay, that is what you mean by exploratory search. So the x in while so uh, on completion of exploratory search. Okay, exploratory search, what we will get is we will get ykn, and if this yk, okay, and if this ykn, okay, is remains the same as xk1, that means in this case yk, that means a is 1, so y1 2 equal to x1 1, that means x1 itself. Okay, so that means if we reach in the x1, in the x1 itself, okay, we started from x1 and we reached in the x1 itself, then what we will do is we will reduce the step, the stepplen, earlier it was delta xi, okay, by a factor of 2, that is we will multiply delta x where I varies from 1 to n by 1 by 2. Yes. Then again we will set I equal to 1. I equal to 1 we will set, and we will go to the we will again repeat the whole procedure. That is, we will repeat from this finding this step 3 onwards. Okay, we will uh, repeat this step 3. Okay, so that we will at the end of this step 3 we will get y. Okay, y k n again a new value for new y k n we will get. Okay, so that is the step 4. Step 4. This is step 4. Now the next step is uh, next step refers to the next next search. Okay, next search means first search is exploratory search, and the second search is pattern direction search or pattern search. Okay, so then what we will get is uh, we have the initial point base point as x1, and we got at the end of step 4 we got another new point, new optimal solution for x that is denoted as x k plus 1. Okay, and in this case it will be x k is 1, so x1 plus 1, so that's equal to x2, right? So we will get, we got x1 and we got x2 somewhere here, x2. Okay, here we got the new optimal solution for x, that is x2. Okay, so what we have, x2 we have, and we have x1, the base point. Okay, then we will go for the pattern search. That means we got a pattern here by subtracting this x2 from x1, that is x2 minus x1, or like in this direction, joining these 2 points, we will get a pattern direction. Okay, so once we got the pattern direction, okay, that pattern direction is equal to denoting it as S. Okay, pattern direction is yes. Then we will find out, we will directly uh, go in that pattern direction, in the direction of S, and we will find a point that is nothing but which is known as the yk plus 1 0. Okay, where this yk plus 1 0 will be equal to is xk plus 1 plus lambda into S, where lambda is the optimum step length. That means here the yk plus 1 will be k is 1, so y20 we will get as sk plus 1 means x2. Okay, x2 plus lambda into S. That means we will go from this x2 in the pattern direction. Okay, like this, in this direction we will go. Okay, with optimum step length lambda in direction S. That means either in this direction or in this direction. Okay, like this direction or in this direction. We will go. Suppose the new optimum point, the correct direction is this manner. Let us assume that. So what we will get a new optimum point, and that this point is yk plus 1 0, or in this case it is y2 0. Okay, so how will you obtain that? How will you obtain this lambda and s? So how will you obtain this lambda and s means you go back to the univariate search method. Okay, in that I have explained it, this lambda optimum value and s. Okay,